All right, everyone. Today we're going to go over five different exam questions. These are from the SOA, and I think they capture a wide variety of topics from bonds and loans to interest rates. So we're going to go over that today. So question seven, a 10,000 par value 10-year bond with 8% annual coupons is bought at a premium. So bought at a premium, meaning that price is going to be greater than the redemption amount to yield an annual effective rate of 6%, or I is 6%. We want to calculate the interest portion of the seventh coupon. Now, typically, as always, like to create a time diagram here. And in addition to the time diagram, we also want to create like our chart where we have duration, the payment, our interest due, write up, write down, and the book value. So let me just create that real quick. So if we have duration, which represents the number of payments that we're at, so 0, 1, 2, all the way to n. Then we have our payment amount. So this will be F times R. And then we will have our interest due, which is going to be I times the previous book value. So it's going to be I times B of t minus 1. And then we have payment interest, and then we have write up or write down, depending on if it's a premium or a discount. And then we have our book value. Book value, one of the formulas is FR minus CI A N minus T plus C. And then there's another one that you can use, which is FRA N minus T plus CV N minus T. And then our write up or write down values, I think was FRA N minus T plus 1. Let me quickly check. If we go to bonds, FR minus CI. Okay, so it's actually FR minus CI A or V, FR minus CI V N minus T plus 1. Okay, so that's our write up, write down. We have interest, payment, interest plus write up, write down should always equal payment. And then we have our book value. So if we go back to the question here, our premium is greater than the redemption amount. We know it's 10,000 par value. So our redemption amount is 10,000, as well as by default, it also equals to the par value, which is the number that we use to get our coupon payments. And we know we have 8% coupons, so our coupons are going to be 800 throughout for a total of 10 years. So if you have duration here, 10 years, a total of 800 is going to be our coupon payment. Annual effective interest rate, 6%. And then 8% annual coupons. We have accounted for that, 0, 1, 2. Let's just label this. Okay, so we have our time diagram set up. We want to calculate the interest portion of the seventh coupon. We know that the interest portion of the seventh coupon is equal to I times B6 times the book value of the sixth. Duration or the sixth payment, and we know that to find the sixth book value, we have this formula here that we can use, FR minus CI AN minus T, not T plus 1. That's one of the things we need to remember for write up / write down is it's N minus T plus 1, and book value is just N minus T plus C. So if we do B6 equals, so R minus I is just 2%. So 2% of 10,000, right? That's just 200. A of N minus T, in this case, N is 10. T is, so this will be A of 4, right? 10 minus 6, and effective rate of 6% plus C, which is 10,000. And now we can simply put this into our calculator. One of the things I want to mention here is how we actually put in the values in our calculator. So we know that payment is supposed to be positive, and we can remember that by the P. And then also future value and present value should be negative. Obviously, if they're 0, you put it as 0, but they should be negative. And then you put in your number of payments as well as interest rate as positive values. So you're able to get B6 in this case. This equals, after you get B6, just multiply this by the interest rate, which is 0.06, and you will get around 642 to be the answer. Now, one of the things that you can actually trip up here is you may think it's I times B7, and you may actually get the book value for 7, and then you multiply by that by 0.06, which is actually an answer choice, and that's actually A. So you really want to pay attention to the detailed wording of the question. This is interest portion of the 7th coupon, which is I times the previous book value, so BT minus 1. So that's what we want to make sure that we do. So that's 7. Now 8. A perpetuity immediate pays 100 per year. One of the things in this question that before I even read the question is the value of a perpetuity, the present value of a perpetuity doesn't change depending on the time. So why is that? Because if I have the value of the perpetuity, if I'm getting $100 every single time step, is the same as even after, let's say, after five payments, getting $100 at the next time step. So because it's a perpetuity, the present value is always going to stay the same, and we can see that here. So perpetuity immediate pays 100 per year. Immediately after the fifth payment, perpetuity is exchanged for a 25-year annuity immediate. So one of the first things in this question is we want to set the present value of the perpetuity at the fifth payment equal to the 25-year annuity immediate, because we know because it's exchange, which is a keyword for equivalent value, is what you want to remember here. So perpetuity immediate pays 100 per year, and then we want to make sure it's after the fifth payment. So we can just 1, 2, 3, 4 set up our time diagram. 100 per year after the fifth payment. And then we have for a 25-year annuity, so this is going to be like 30. So this will be, let's say this is 0. This is until like, let's just say like this is 1 from the 5 to 3 until 25. Okay, so we want to equate the present value of the perpetuity at time period 5 after the fifth payment to the 25-year annuity immediate that's being paid out 25 years. And they're going to pay X, and it's going to increase by 1.08. So this will be 1.08 times 1.08 squared, and so on. So how do we do this? First, we want to get the present value we want to set our comparison date to 5. What's the present value of this perpetuity immediate at time step 5? And that is equal to just 100 over I as our formula here, the payment over the interest rate. And we want to make sure, as I mentioned before, that this value is the same regarding if it was at the sixth payment, seventh, eighth, ninth, or even the fourth. This value is going to be the same no matter what payment you're at, because you're going to get this payment you're going to make this every single time step. So that's one of the key things. That's one of the trickier problems. You may want to actually like discount this back, or you may want to see what's the accumulated value at 5 and treat this as an annuity immediate, and then see what's the accumulated value here. But you have to remember, and this is the sort of the tricky part of this question, is that perpetuity immediate, the present value of that is always the same no matter what the time step is. And so we have 100 over I, and that we can set that equal to, and now we can do just the summation here. We can do X plus, it's going to be XV, right? If we discount it, XV plus X times 1.08, B squared plus X times 1.08 squared, B cubed, all the way until we get to X 1.08 to the 24, B to the 25, because it's for 25 years. One of the things that you will notice here is that the interest rate is equivalent to the increase in the payment amount that you get at each subsequent payment. And so the simplification that this does for us here is, if you could think of this as V is just what? 1 over 1.08. So what you're doing is you're multiplying 1.08 times 1 over 1.08 squared. You're always going to discount 1 year more than the factor that you're going to be increasing by. So in this case, we're 25, 24. And so what this does, and because though these two are the same, the effective rate of interest as well as the percentage by which the payments are increasing, you can essentially cancel those, and these all just become XV plus XV plus XV plus XV 25 times. 25 times, right? Because 1.08 to the 24, 20 to the 24 times 1 over 1.08 to the 25th. And then we can see that same pattern applies for each of these terms. And so we can simplify that to 25xb. And so our 100 over I is over here. 100 over I is over here. Now we have all of the things that we know. I is 0.08. B is 1 over 0.08. 1 over 1.08. And then we can solve for x. And once we do that, we get x as a 54, which is our answer here. So one of the things about this problem to know is you want to write out the summation. So when you write out the summation, you can see the actual formula. If you try to use another formula, that I think the denominator has like I minus k, which turns out to be 0. But you can use a simplifying assumption whenever the effective interest rate is equal to the rate at which the payments actually grow. And so that simplifying assumption leads us to make all of the terms essentially xb, which makes our lives a lot easier. And so we're able to do that. And then another thing is to know that the present value of a perpetuity is always going to be the same no matter the time step. This is a key concept we want to note here. So even if it was after the sixth payment, even if it was after the seventh payment, the present value of the perpetuity is going to be 100 over I, no matter what payment that, no matter what time step you're at. Okay, so now, so let's just write, so those were the two things I wanted to point out. Let's go to question through 10. Question 10 refers to Ernie makes a deposit of 100 at time 0 and x at time 3. The fund grows at a force of interest at t squared over 100. The amount of interest earned from time 3 to time 6 is also x. So what we want to see here is that the amount of interest is essentially the difference between the amount at time 6, so amount at time 6, and the amount at time 3. Amount at time 3, right? Assuming that no additional payments are being made. And so first we calculate what's the amount at time 6. The amount at time 6 is we make 100 at time 0. So if we just have our diagram here, time 3, 6, we have 1, 2, we have 100 at time 0, we have x at time 3. What's the amount at first? Let's get the amount at time 3. Amount at time 3 is this x that's already at time 3 plus this 100, and we have to accumulate that by this force of interest. So we can do that by saying 100 e to the, in this case, because we have a changing force of interest, because it's a variable force of interest, we take the integral from 0 to 3 of t squared over 100 dt. That's going to give us the accumulative amount of that 100 deposit that we had at time 0 at time 3. And so we add that to x, and so that gives us our total amount or total value at time step 3. Now that equals, now if we add an additional x, this is the amount that we have, this is the interest that we have. We know that the amount of interest earned from time 3 to time 6 is also x, so that's where this additional x is coming from, is the interest that we're adding. Now that should equal the amount, the total the value that we have at time step 6. Now what's the value that we have at time step 6? That's 100 e to the 0 to 6 over here, t squared over 100 dt, plus our x is also going to be accumulated from 3 to 6 of t squared over 100 dt. So once to reiterate, this 100 is from at time step 0. We're accumulating that by the force of interest to get the value at time step 6. This x, we made the deposit at time step 3. We're accumulating that 3 years to get the value that it will be, to get the value at time step 6. And so this x is what the interest portion that we want to solve. And so we have a pretty standard equation here that we can solve for x. And once we do that, we get x is around, I think, 785. So that's our answer here. E. Okay. Let me just quickly check. Is that the, yeah, 54? This one was 54. This one was 785. Yeah, this one's 785. Okay. I won't go through like, and again, I'm just going through high level, like how to solve these questions, just setting up the equations, because then you just have to like plug and chug into the calculator and get the answer there. So 87, a company takes out a loan of 15 million at an annual effective discount rate. So that's D equals 5.5%. What's the relationship between D and V? 1 minus D equals V. So we know our V is 0.945. And again, let's make our time diagram here. Loan is being repaid with annual. We know that it's with annual 1.2 million plus some drop payment. Again, drop payment is a year after the nth payment, right? So if we have n equals 10.236, what you could do is you can make a payment, some additional payment at year 11 because it might not make sense to make a payment of that amount at like time step 10.2.46 or whatever. So that's why we have the drop payment and balloon payments in the first place. So here we have takes out a loan of 15 million, company takes out a loan, and the first payment is actually due 3 years after the initial loan is taken out. So let's just accumulate this by 3 years. We have 15 million times, we have this I over here, right? We want to convert this to 1 plus I, which is just 1 over V, accumulate by that by 3 years. So the value at time step 3 of this loan is this amount that it's going to be that's going to have to be paid. And now we know it's going to have n annual payments. So we know that until 4, 5, until like n, right? Or let's just say it's going to have n annual payments where we're starting at 1 payment, 2 payments, to n payments. We know now that this is going to, again, this is standard loan problem, annuity problem here. 945 cubed equals our 1.2 million, a to the n. We know I is, I think it was like 1 point, let me just calculate 1 over 0.945. I is around 5.8%, 5.82%. And then we know that there's going to be an additional drop payment. So that's X going to be made at V to the, we need to find what this is. So first we find what N is by plugging this into our calculator. As we mentioned, we want to be really cognizant and aware of the fact of the signs that we're plugging in when we put this into our financial calculator. So I believe N in this case was around And in this case, I think it was, what was N? Where'd it go? It was around 30, or it was 29. Yeah, it was 29 here. It was 29, it was 29 point something. And so we know that this V is going to be V to the 30th. V to the 30th. And this N we got like 29 point whatever. So in this case, we can just leave this as 29. And then we solve for X, and then we're able to get our final answer. One of the key things I want to point out here is A, how you're plugging these numbers into your BA2 plus financial calculator. You want to make sure that the present value is positive, is negative, future value is negative, payment is positive. So in this case, what you would do, so to get N, what you want to do is you want to plug in payment is positive, so that's going to be positive 1.2 million. Our present value is going to be negative this amount, right? It's going to be negative this amount. And then our future value is going to be negative, but in this case, it's going to be 0. That's how we're gonna, when we plug in and then we insert our I, be 5.82%, and then we get our N to be around 29 point something. And then so we plug this into N, and that's our N, and then our V is then 30 because we're making that drop payment at the 30th payment. And then, yeah, that's how we solve question 87. Now 88. So this, and again, as you get more practice with these, you may even skip drawing the time diagram if it takes a long time, but really to get an initial foundational understanding of how to actually do these types of problems, you really want to just draw out the time diagram over and over again, create those tables, those charts, just so you can get used to it. But after a couple of practice exams and after you've been doing these problems for some time, you're able to sort of recognize what this problem is asking you to do and sort of almost skip the time diagram problem. But first, that requires you to actually do the practice and questions first. So 88, Tim takes out an end-year loan with equal annual payments at the end of each year. The interest portion of the payment at time n minus 1 is equal to the interest portion of the payment at time. So what is the formula for the interest portion? It's R minus 1 minus V n minus T plus 1, right? That's the formula that we use when we are calculating the interest portion. So how are we able to do this? Well, let me just pull up, I think, a version that I have here just so I can. All right, there we go. Okay, so this is the formula for the interest payment. Again, you can draw out the time diagram, you can draw out the table, but this is the formula for the amount of interest that is being paid out, right? And then the principal amount is RV n minus T plus 1. And then the total payment is R. Remember, like those three columns in that diagram, in that chart. We know that the interest portion of the payment at time n minus 1 is equal to 0.525 of the interest portion at time n minus 3. So we can set up an equation here of V of n minus, in this case, it's going to be n minus 1 plus 1. In this case, we are going to cancel out the n's, and then this will give us 2. That is equal to 0.525, 1 minus v to the 4th. Right? We went from a minus 1 here to a 2 here, going from minus 3 here to a 4 here. And now this we can solve first for v, and we are able to get that our v is equal to 0.951184. Now we can use this to solve for n. So we know that our v is this, right? We know 1 minus v squared. And now we know we can set that equal to 0.1427 of the interest portion of the first payment. That's just R minus R1 minus v to the n. Right? So this, again, we have our v, cancel out the r's, and we can solve for n, which we get to around 22. One of the things you want to know for this question is how to solve this efficiently. So you can see like the r's cancel out when you set these two equations equal to each other. So there should be an r, these r's cancel out, these r's cancel out. And so sometimes whenever you don't get like a value that you think you should be getting, a lot of times that's because when you go through the formulas, when you go through the equations, the values actually end up canceling. So that's something that you want to be mindful of as well. So those are the 5 problems that I wanted to go over. Again, just some high-level takeaways is that you want to be very careful in terms of like having a good attention to detail. And the first question, the interest portion of the 7th payment, you could have accidentally just calculated the book value of at the 7th instead of using the previous book value. So that's a common mistake. In question 8, what you could have done, a common mistake you could have made is you could have treated the 5 payments of 100 as an annuity immediate and calculate the accumulated amount at time step 5 and set that equal to then the perpetuity, the geometrically increasing perpetuity. And so we have to remember that the present value of the perpetuity is equal no matter what the time step is. So that's an important thing that we want to keep that we want to be aware of. Question 10, again, just understanding concept of force of interest. Sometimes these questions are going to give you a varying force of interest. And so just making sure that you have the calculus down. Maybe instead of t squared over 100, it's some other function. And we want to make sure that we know how to integrate that. For question 87, I think one of the things to note here is making sure you're plugging in things into your calculator and your financial calculator correctly. So making sure that your signs in particular are correct, because that's a common mistake as students. People taking these exams don't have the correct signs in the calculator. When you're plugging present value, future value, the total number of payments or interest rate, the signs could be a bit off, and that's going to ultimately give you an incorrect answer. And so we want to make sure that present value, future value are both negative. And again, if it's non-zero, as well as the payment is positive. And so that's going to give you a more accurate answer. And then I think that's about it. Let's go into NFL predictions. Let's go into NFL predictions. So last week, the Ravens did win, and we had that trend going for us. Lamar against NFC teams, as well as the Cowboys already upsetting at 325 and one. So now in this week, I have Jets money line, I think, which is like 480 or something. And the reason I think this is because I think the Jets, they just won Thursday Night Football. I think they're going to continue winning these next couple weeks or so. And yeah, Jets money line minus 180. A couple of other games that I think I'm not gonna make it like an official pick, but Bills Ravens. I like the Ravens. Again, not official pick, but just like leans, I could say. I like the Ravens money line because it's Bills versus Ravens. It's at Baltimore for number one. It's at Baltimore. Ravens are the favorite, as well as Bills have already upset in a primetime game this season against the Dolphins. And I also think the Jets win the division, and so Bills feel like are going to slip up here in some time. So Ravens money line. Also, I think Packers money line. And the reason, so I'm going to go Packers money line, and then what was the other game? Yeah, Packers money line. Ravens money line, Packers money line. And the reason Packers money line is because next week, I think the favorite in the Jets Vikings game is going to win. And if the favorite, and it's most likely the favorite's going to be the Jets. But if the Vikings are undefeated, it's very rare for a team to end an undefeated season, like 4-0 or 5-0 or even 3-0, 2 years in a row. So if this was the case, if Vikings did win, Vikings would be what, 4-0, and then if the Jets were favored, actually, the Jets would, they would be the first team that the Vikings lose by. But the Jets have already done this last season. So I think what happens here is that the Vikings actually lose to the Packers, and then they also lose to the Jets the next week. But again, not this is just a theory that I'm predicting, not like official pick here. But these are just some initial leans I have: Ravens money line, Packers money line. But my official pick that I feel pretty confident in is Jets money line minus 480. I think the Jets continue to win. Rodgers continues to build his MVP case, that the trend that we've already talked about before in previous videos. And then a couple other things I want to go over, a couple of other learnings I had this past week is number one, the amount of motivation that you have to do a task, to engage in a certain sort of activity determines the level of success you have in that endeavor or that activity. So you really want to have this attachment to logic, attachment to the activity that you're doing, in which you're constantly thinking about, you're constantly like almost obsessed with it. And you want to make it easy and effortless for you. It shouldn't be difficult. Yeah, it's obviously going to be difficult, but the more that you used to get, the more you get used to a certain piece of activity or task, it should naturally become effortless to you, and it should become easy to you, and it should become something that you enjoy doing. You're attached to it. And so that's one of the things that we really want to keep in mind is that any activity that we're doing, any task that we're engaging in, we want to have this emotional attachment, this emotional engagement, this love, this joy for what we're doing. It's almost like an addiction, like we're addicted to to doing this task and to doing this activity, and that's going to yield very good benefits for us in terms of just how the amount of success that we have. Because really, I believe that the amount of motivation, that internal drive that you have to do a task is really going to propel you forward. And really, in fact, I think it's the niche parts of an activity that really captivate you, allow you to shine even further. So in the case of Kobe Bryant, it wasn't like shooting that game-winning shot or shooting or really like the game of basketball itself, like almost it feels weird to say at a high level, but what he really enjoyed was the mundane, like how the ball bounced. He loved hearing the ball bounce while he was at practice. He loved the way that the ball felt. And a lot of that's weird, but the more weird of a passion it is, it actually transforms into something greater and that you're able to really attach yourself to. And so really try to find a really niche thing, almost like a weird part of the task that you're involved in that's really addicting and that's really fun. That's really going to have great benefits in the overall your success of that task or activity. So those are just a couple of things that I had throughout the learnings that I wanted to share throughout this week. And yeah, that's about it. See you in the next video.